Okay, I think, Jan, we can get started, and we will be recording this meeting anyway. So welcome everyone to this first webinar of the FAME webinar series that we are planning. My name is Mariana Jaralambus. I'm a project manager at Innovact, and I'm pleased to welcome you all today in today's session titled StreamStory, where time series meet explainable AI, a visual journey through data. So our speaker today is Jan Šturm. I hope I pronounced it well. From the Jožef Stefan Institute, and we hope that this webinar will shed some light on how we uncover meaningful data stories with AI. So just a couple of housekeeping notes before we start. This webinar is recorded, so you will have access to it afterwards. It will be uploaded on our YouTube channel and FAME Learning Series. Learning Center, and of course feel free to type any questions you have. So we'll have some dedicated time after Jan's presentation, so we can answer any questions you may have. So without further ado, Jan, the floor is yours.
Okay, so I'm Jan. I'm from Jožef Stefan Institute, and I will represent you StreamStory. Okay, so let's first jump to the opening question. What are your first thoughts when you see a chart like this? Do you maybe become anxious about it? If I say for myself, I become anxious when I see such chart because it's difficult to explain it in a few moments, what's going on here and which patterns we can extract out of such chart. So this is the problem we are addressing with the StreamStory. So StreamStory is a tool for interactive explorative analysis of multivariate time data. And key challenges addressed here are understanding complex temporal patterns, then handling large multivariate data sets, where we have in mind like big data, sensor readings, and so on. And also at the end to deliver explainable insights to the users so that they can at the end understand what's going on. Okay, so why StreamStory? So the core purpose is to make complex data understandable to domain field experts, which might not have expertise in analyzing such data. So idea is that first the data analyst process data, and then domain experts helps data analyst to properly validate such models. So key technical features here are to perform interactive visualization, but we will look at visualizations later. So then to do multi-scale exploration and using LLMs to automatically detect patterns in data. So main benefits of this is to save time in validation process using LLMs, to solve also communication challenges, and emphasize trustworthiness and explainability of results. We will also see later why this tool is explainable, and we applied novel approach using LLMs to interpret complex data patterns. Okay, so I will provide you high-level picture how StreamStory works. So at the beginning, we have multivariate input data streams. For example, the top stream could be temperature of the river, and the bottom one could be like flow of the river. So then we convert time series to point cloud. So point cloud are basically vectors in a vector space. Here are projected to do 2 dimensions that we can actually see them. And then we apply clustering algorithm to partition space. In next step, we we calculate transitions between those states. So in the previous step, we got just clusters, and now in this current step, we got also transitions between them. So to get Markov chain model. But you can imagine that before, if you remember, we mentioned hierarchical Markov chain. So idea is that at the beginning, we have like more abstract states. For example, we would say river dynamics, for example, like in winter, summer, autumn, and spring. Then when we would drill down, we could see more finer patterns. For example, in winter, we could see that there are more specific dynamics, which we will also see later on. Okay, so StreamStory has also user interface. So idea is of StreamStory that anyone with technical or non-technical expertise can use this tool. So here we can see Markov chain. So maybe if you don't have any pre-knowledge about Markov chain, so idea is that in each state, for example, if we are in rainfall highest in this state, we have 0.95 probability to go in state October, and then we have 0.5% probability to go to another state. So this small probability is not visualized here because of visualization concerns, because it can become a mess. But the idea is that from each state, all outgoing transitions should sum to 1 or 100% probability. And this is the case that I mentioned before. So here in A, we have abstract layer. So we have rainfall low and rainfall highest. When we drill down, we can see finer patterns. And then in the last level, we can see even finer levels, finer dynamics. So this is calculated on the past data. Okay. So, but now we don't have intuition, for example, how those states were transitioning between each other. So this is now the visualization on the right. You can see multiple levels. For example, each level here, each row corresponds to one level of Markov chain. So here we can see, for example, first is red, then is followed by purple, and then blue one, and so on. So we can see in time in which states time series was. If we click on arbitrary state, we can also see distributions of the values. For example, on rainfall highest, we can see that there was that values were on the right side of the distribution, and also temperature was on the right side of distribution. So those states are labeled automatically, and StreamStory has also capability to calculate time distributions. And state labels are extracted using explanation tree. So on the right, you can see now those time distributions that I mentioned before. So if we click on particular state, you can see in which months data points occurred. For example, if we would click on this rainfall highest, then we might see that most values were in January, February, March, and then November and December. And if we would click on another state, we could see that those values were more aligned with summer months or like early autumn months. So those states have also particular colors. So those colors are also assigned automatically. We will later see the algorithm, how it works. And upgrade in the same project was applied using LLM. So, for example, here we can see some patterns, and those patterns might be, okay, we can spend a couple of minutes to analyze those patterns. So some are recurring. So here we can see gray, brown, and green, and this is recurring. But imagine that we have 50 years of data, and data is resampled to 10 minutes. So this can be quite challenging to extract all patterns. So we try to use LLM that it first extract recurring and anomalous patterns, and then we used LLM to explain those patterns in human readable form. So we forced LLM then to also, based on the context we gave him, to provide us intuitive explanations why these patterns was first found out and what is intuition of these patterns. Okay, so before I mentioned state color coding. So you can see on the right we have this color wheel, and we assign each initial state to one position on the color wheel, and it gets proportion of the wheel depending on how much time was spent in that state. When we merge together states in this hierarchical Markov chain, we first have those little states, then we merge them together in a higher state. So when those states merge together in higher states, also those colors are mixed together. And more abstract state is like darker is, and more specific is colors are lighter. Okay, we have also multiple case studies. So first case study is weighted data analysis. I already showed you this example before, but we can tell a little more about it. So the data set contained 20 years of UK weather data for one specific city, and variables included temperature and monthly rainfall averages. In this particular case, were discovered several things. For example, seasonal cycles. For example, you can see here like May and October that are also among the states. Then some weather state transitions and temperature rainfall relationship. Before I forgot you to mention one thing. So idea of StreamStory is to put arbitrary multivariate time series. So it can be either finance or weather data or traffic data. So we just need, at the end, we need proper time series data. Then another case study was GPS tracking analysis. So this data set contained like 3.5 years of GPS data of a single person, and that person was traveling around the world. So mainly this person was located in Slovenia, but he also traveled to US. So on the most abstract layer, we can see on the left, you can see European Union, and then we can see US, and on the right, Asia. So when that person went to the USA, there was 100% probability that he returned to European Union, and it was 50% probability from European Union to go to US, and 30% to go to Asia, and so on. Then when we drill down, we can see inside US, we can see like Texas, New York City. In Asia, we can see China. And when we go to the finance level, we can also see some Euro trips like Croatia, Italy, France, Spain, Greece, for example. And in US, we can also see Dallas, Austin. So here were discovered like travel cycles and geographic clusters. Then the third case study is the wind. So Slovenia has one interesting city which is called Ajdovščina, and it's famous about by its strong wind called Bora. We call it Burja in Slovenia. And here data was measured for March 2016 in 10-minute intervals. So variables were wind speed, direction, and their changes. And in the finest level, they identified like three main groups. Like first was like column winds, which can be identified by low speed and variable direction. Then was the strong bora, which was specific that it's perpendicular to the ridge, and then was weak bora, which was along valley direction. So we can see those labels on the top of each sub part of Markov chain. Okay, now let's jump to the case study number 4, which is related to FAME Pilot 7. So input data set was all refinery data, also including the system failures and maintenance periods. So each row in this chart represents single sensor. With green color, we visualized values which were kind of normal in sense of thresholds that were defined. For example, on the top, you can see with purple one in the top chart, you can see purple color, which represents values which were over the threshold, over the maximum threshold. And with red color, we can see the values which were under the minimum threshold. There are also two bands. First one is the yellow band, which represent maintenance periods. And there is also red band, which represent failure periods. So here we have sensors for temperature, pressure, and flow for multiple machines. And this chart is kind of similar to the one that you noticed in the first slide. You know, it's also a bit challenging to understand data in a few moments. Okay, so in the first iteration, we built several StreamStory models. So on the left, we can see Markov chain. On the right, we can see state transition history. Okay, so on the left, we can see that we included like temperature, flow, and pressure. So we can see how in time, how we travel around those states. On the right, as I mentioned, we have state transitions. On the top one is the original one. And we can focus on one particular part of it. So the top right state transition history is a kind of not really intuitive. You can see a lot of mixing between the colors and the states. We can also see the timeline. You know, here is Tuesday, 5th February, and here on the bottom one, we focused on the February so that we can more clearly see those state transitions. So for example, here we transition from green to red, back to green, and then to the light red and red one. But at the moment, if we agree, we don't have really good intuition what's going on there, except that we have Markov chain, we see some transitions, but we cannot tell a story about it, which is also limitation of the current StreamStory implementation. So in a FAME project, we actually took this challenge because manual analysis of state transition patterns can be challenging and time-consuming, and we would need highly rely on expert knowledge. So proposed solution here was to leverage LLMs to analyze those Markov chain. So input was historical transition data, which we saw here on the right. And we also provided contextual descriptions about the data. For example, if there was a sensor for temperature, we also provided metadata and descriptions that were provided by company. So LLM could better reason about extracted patterns and also reasoning what this pattern was considered to be recurring or anomalous. And output was for those patterns that I mentioned, and also explanations of the patterns. So as I mentioned, so on the left we have time series, we have time transition that was input, and on the right we have output of the LLM. So first column represents sequence of states. For example, here we have flow high on the top left, and then flow highest, and then pressure lowest. So this was sequence of colors. So let's imagine that first state is brown, second one is green, and the last one is purple. So this was identified like recurrent state, a recurrent pattern. It was found in time period from 3rd February to 5th February. Here we have also short description and intuitive insight, which was generated based on the extra context that we provided to LLM. But this LLM approach also needs validation by domain experts so that we don't provide like hallucinated explanations to the end users. Okay, let's getting started. So if you want to integrate StreamStory to arbitrary website or arbitrary code base, we also provided here a few links. So if you're just non-technical user or even technical, but you just want to try it out how this works, you can access this on web application on this link, on the first link. In case that you would like to run your own instance on your own server, you can also clone this code and run it easily using Docker. And input data to StreamStory requires currently CSV format. Time series need to be aligned, and there is one most important requirement, which is proper pre-processing of data. So time series needs to be aligned. Missing values needs to be handled. It's also good if we normalize data and do some feature engineering. Because feature engineering, in a sense, because under the hood k-means is used, and if we provide too many features or features are bad, also at the end, those Markov chains won't be as expected. So here is, first we can build models using UI. I will also later show you in a live demo how you can do it. So we upload weather data, then we select input attributes, then we say which time attribute we want to use. This approach is good for testing and to get intuition how this works. But in case that we want to process like large amount of data and try various models, various combinations of attributes. So here we recommend to build models automatically. So that's why we implemented API, which includes Swagger documentation. So API is recommended maybe just to test it with Postman, or if you have C++ code base or non-Python code base. In case that you use Python, we recommend Python library, which is called StreamStory. You can install it easily with pip install StreamStory, and you can start like in a couple of minutes. You can build your own first StreamStory model. Okay. If you have some questions before we jump to the demo, you can ask. Otherwise, we can also answer questions after the live demo. Okay, so let's now jump to the live demo. I will just switch the screen. Okay, so this is StreamStory website. So you can register and log into this website in few minutes. It's completely free to use. And if we go to dashboard, so we have two kinds of models. So first are private models, which we are not intending to share. And we have then public models, which we are intending to share with public audience. So private models can be also shared to specific group of people, so we can integrate them using API keys. For example, if you go to my profile, here we can, for example, we can set API keys, and those API keys are used to integrate StreamStory models to arbitrary websites. And websites without that API key cannot render those models. So let's first upload our Hello World model. So I will use weather dataset. Here we select all attributes. So in most cases, it's also recommended to, but it requires some testing. But in most cases, we find out that StreamStory models work also better if we include previous time step values. So here is just shifted by 1 month. So rainfall previous month, then temperature and temperature previous month. Then we select time. So for time attribute, there is also one requirement, which is that it's pre-processed in a Unix format, but we will in future provide more flexibility, so that you don't need to convert it to a Unix. In case that we would have categorical types, we could also select here that it's categorical. And here we can also select derivatives, which in some cases also help to generate better models. We use k-means and 12 states. This can be changed. Okay, and let's call like weather webinar 10. Okay. Now we click on this icon, we can open our model. And now we have this most abstract layer. We can see like colors are not bright. And when we drill down, we can see that colors are getting lighter. And colors that are more similar to each other belong to common previous states. So here we have multiple levels. We can zoom in or zoom out with mouse. So now we see only state history, but no other things that I mentioned before. So to see distributions, we need to click on state. And now we can see, for example, in temperature previous month highest, we can see where those values occurred with blue color. So, and this gray distribution is shared among all the states. So all states share green part, gray part, only the blue part is changed. So it depends where values were. Now we can, for example, now can you hear me otherwise?
We can hear you. You just frozen for a bit, but we can hear you.
Okay. Okay, so now we can see that it's not very clear, how those state transitions were. So now if we zoom in, we can better see. We can better see for particular time. So this data set is not ideal because here time was not pre-processed correctly. It didn't use Unix time, but here you can imagine that this might be 2 p.m. Today, and this might be 3 p.m. today. So we can see how we were traveling around those states. For example, let's say that we are in this state, then we jumped in next. For example, in this hour we are in purple state. Next hour, in next time step, we jump to the brown one. But this one you can see it's wider, so it means that we spent here a couple of hours in this state. So this is the idea behind this. And also for each state, we can see time distributions. So here is hour of day. So this was in morning, and then in afternoon and night. Okay, here months are not clearly separate. Let's drill down. But you can see that some months are more represented than others. StreamStory also support, for example, when we built a Markov chain on the current data. So if we would have now new data, we could then simulate how we would transition in those states. So if we have now a transition history just for past data, then this history would be extended, and we could see also for incoming data in which states we are. Okay, and now I can also quickly show you how to build model using Python library. Okay, so as I mentioned before, we created Python library. It can be easily installed, but we also included a simple example in library. So we have here river flow data. So timestamp is given in a such ISO format, and then we have river flow value. So idea is to first load API key and API link. Then we initialize StreamStory client. We can do also some pre-processing if needed, so we can resample to daily values. We can add then previous day value, previous value of flow. And here is a boilerplate code so that we can generate this StreamStory model. So as you remember, before we selected attributes in UI, in similar way, we here define which attributes we want to use to build a model. For example, if we would like to try without this river flow previously, we would just comment it and we would get a new model. Here we also support some operations, so you can include derivatives and some other operations which are also described in documentation. Here we defined a number of states, a number of histogram buckets, how this model will be called. Here we define if it will be public or not. In case that it's private, we can use API key to make it public only for particular websites or applications. And then we just here build a model, and in case that model was successfully built, we get a notification. Okay, so next steps include validation of StreamStory models with the main experts. I have in mind mock all refinery data. So we came to the point that we got models, but then we need to validate. So which particular level in hierarchy is the one that is most useful to the end users, and also if there is needed some extra pre-processing, that models would be more informative. So in development is also this LLM extraction of patterns. We also need to evaluate this approach, and we might combine this with pattern extraction algorithms which are widely used in a general, and compare results, and also to apply those approaches in pilot 7 of FAME project. So if you have any questions, you're welcome to ask.
Thank you, Jan. That was a very insightful presentation. Feel free to ask any question you may have. I have a minor question, Jan. I was looking at the presentation and from a user experience perspective. You mentioned that you referred to non-technical users. So I was wondering if you, how easy the tool is, to be used by non-technical users, and if you already had some feedback, let's say, about the tool being and its used by non-technical people.
Okay, so if we go maybe to an example, yeah. So maybe the most challenging part at the moment for non-technical users is just to prepare data. So if you have a bit of expertise how to prepare data, you're already on the safe side. So one thing which might be challenging now is to pre-process timestamps, which I mentioned. So we are working on this as well. So this is now one like obstacle, might be one obstacle for non-technical users. And it would need maybe a bit of, each non-technical user might need a bit of time, to get used to those visualizations, which might be a bit not non-intuitive when you see them for the first time.
Okay.
But that's why also when I mentioned LLMs, which might also break those obstacles, and to help to explain those models that we can get first intuition what's going on.
Okay, thank you. And since you referred to LLMs, there's a question from Fabiana in the chat. I'm wondering how the prompts to the LLM are done.
So at the moment, this is kind of semi-automatic. It's not completely automatic. So to LLM, we provide screenshot of Markov chain. We also provide JSON with how things are structured, and time series, this state transition part, and then we force LLM so that in tabular form that it provides us all things that I mentioned before. So so that in tabular form it provides us those columns, so sequence of states, type of pattern, time, short description, intuitive insight, and one additional input is also context about each input feature. For example, that for temperature sensor we say, this is temperature sensor on this machine, it measures those things, it has those specifics, so LLM then knows better how to explain us this intuitive way. So it's also related to quality of data descriptions that we provide to LLM. I hope this answers your question.
Thank you, Jan. Well, Fabiana, if you have any follow-up questions, feel free to write in the chat or unmute yourself. We also have another question, Jan, from Basil. Does your solution help in fact-checking, especially weeding out bad information or corrupt data?
Do you have any particular example? So, like more specific, I will easier answer then.
Basir?
Hello, Jan. I recently took part in a information integrity conference, and the biggest complaint was, the colossal amount of work fact checkers need to do. So in that regards, there seems to be a potential there. So I was just curious whether, I mean, obviously, probably this is not something you have done before, but whether do you see any future potential? So it's a speculative question.
So what would be your example data set, like input? For example, if you mention few columns.
I mean, I'm not a data scientist, but just from a perspective of, in a way, how are we able to vet data a little better on the perhaps news environment and just narratives?
Yeah, so
more of content analysis than actual hard science data.
So we also tried with news in past, but it needs extra pre-processing, and StreamStory is not actually, it's not it was not built for this particular case, but then we had like modified version of StreamStory so that you can also put news, and you can see, for example, that there are elections in US happening, and then you have, for example, Olympic Games and those things. So with this, you might notice some normal behaviors which you can expect, and you might also detect some abnormal patterns.
Okay, are there any other questions? If not, we can end the webinar. Thank you, Jan, again for the presentation. And this was, as I mentioned, was the first webinar of a series of webinars that we will conduct. So I will share the registration links for the upcoming two of the webinars that we're planning. So feel free to register. We'll also follow up with an email. And yes, as Ernesto said, of course, we'll populate the FAME marketplace with the asset, and we will also upload the webinar in the Learning Center and YouTube channel. So thank you, everyone. Thank you, Jan, again. Great presentation. And have a great day.
Thank you all for joining. Okay, goodbye.
Bye.
Thank you. Very nice. Bye-bye.
Thank you. Bye-bye.
Bye.
Thanks. Bye.